Good afternoon. I'm Piotr Czaplicki, and this is my friend Maciej Baka. We are from Białystok University of Technology, and we will show you our presentation about Mars Rover Analog Integrated Controller based on real-time operating system.
Good afternoon. We took part in a project #Next in Białystok University of Technology. In this project we designed and tested our own Mars Rover controller. It was used in Red Rover, which was competing in University Rover Challenge 2016 in Utah Desert, and European Rover Challenge 2016 in Poland. Mars Rover control is complicated and complex process which requires a combination of a variety scientific fields such as informatics, electronics, geology, and geography. Creative control system for Mars Rover Analog needs not only realize of steering algorithms, but also use information about landform and geographical location of research place. Our integrated controller was prepared mostly as universal system and can be a heart of not only Red Rover but any vehicle with electrical motors. Basic assumption of our controller is modularity. Both electronic and logical function of controller was divided by 3 modules. Each of these modules can work almost independently. That allow easy development of our control system and testing of each module. Integrated controller was prepared for Mars Rover Analog. That kind of rovers was steered by human operator, which was with robot on Mars. Because of our control system doesn't allow to autonomous exploration of Red Planet, although system has elements of autonomous to make easier robot control. We can extract 3 modules: main module, drive module, and robotic arm module. Main module is responsible for receiving and transmitting data from and to operator, calculating driving path for autonomous driving, and reads data from sensors, applying to soil sample research. Drive module can read data from drive motors encoders and precisely control rotation speed of each wheel. Arm module is responsible for steering robotic arm with use of encoders and potentiometers and control sample collecting device. Each controller has STM32 microprocessor. This makes it individual, which can work without another controllers. The division of tasks for several microcontrollers allow us adopt additional protection algorithms. Each controller is connected to radio modem. In base functionality, solid line on the graph, is transmitted steering data to main module with RS232 interface, and then to ARM and drive module via synchronous interface. If main module doesn't work, data to secondary module are transmitted with USART, and then ARM and drive modules capture data directly from RS232 interface from radio modems. And then if that works correct, an operating system is a computer program that supports computer's basic functions and provides services to other programs. Most operating systems allow multitasking. If processor has 1 core, it runs only 1 task at the same time. Operating system use scheduler, manager of system, which provides the illusion of simultaneous execution by rapid switching between each program. Adopting of real-time operating system allows programmers to avoid a lot of problems, which they may encounter in developing process. The base of advantage of FreeRTOS is easy of software, portability on other platforms. Thanks to them, software is more universal and more valuable. FreeRTOS offer also manual security system, for example, supervision over tasks, which protect system from halting in the infinite loop. System allows developers for easy independent functionality of application through placing them in separate tasks. However, use of FreeRTOS requires from designer prediction that operating system needs more resources than application without RTOS. Additionally, access to peripherals is prolonged in view of extra system operations. Drive module main task is steering drive motors. On the module are placed 3 microcontrollers. 2 of them are responsible for receiving data from encoders mounted on DC motors. Third microcontroller, the MI1, is responsible for receiving information about angular velocity of each wheel. Then, after a few calculations, it generates steering signals. The whole algorithm is divided into 3 tasks. First one receives data from main module. Second one receives data directly from radio modem in case of main module failure. In third task, microcontroller is calculating PWM values, which are generated on pins connected to motor drivers. To calculate this, there are 6 PID regulators, 1 for each wheel, where the set point value of the regulators are velocities of wheels set by computer application. Where values are actual velocities received from encoder microcontrollers. To get these values, the main microcontroller asks each smaller one in 100 milliseconds interval. Expect normal driving, there is an option to use digging mode. In this mode, user can choose which wheel will be digging. Then the rest of wheels are using PID regulators to keep rover in place, and chosen wheel is steerable by sending specific drive. This mode is very useful to prepare soil to get sample from level below the ground.
Thank you. And now the second controller of our module of our controller. And robotic arm module is responsible for controls manipulators and sample collecting device. We can also connect to this module another devices with DC motors or servos. In this module, we have divided algorithm between dry mode, and the first is achieving a desired position. In this mode, we use in this algorithm we use a pit regulator, and the second stage of this mode is pre-programmed desired position. Also, we can write to our controller position we use often, and then manipulator controller desire this position automatically. And the third mode of algorithms is inverse kinematics mode. In this mode, operator can move gripper along the axis of the Cartesian coordinate system. Software and in FreeRTOS we have create 3 tasks. The first and second task is responsible for communication. The first with main controller or radio modem, and the second with encoder module. In the last task, we have implemented kinematics algorithms. And now the main module third. This is controller, telemetry controller of our robot. And on board this model, we placed IMU sensors, temperature sensors, a GPS module. We can take measurement from these sensors and sending to operators. On this model, we have used redundant interfaces, and that allow us the easy development of this model. We use variety of interfaces, I2C, USART, or ADC converters. This model is also responsible for acquisition data of about soil sample, and the main functionality of this model is converts all information about IMU sensors, about GPS, about soil sample, and transmit this information to operator station. The additional functionality of this model is autonomous drive mode. Operator can send to controller position of GPS position of a point, and rover can autonomously drive to this point. And in this model, software we have divided between 7 tasks. 6 is work all of the time, and this is receive data from radio modem, receive data from GPS module, IMU sensors, read live sensors. The main task, data analyze and calculate control algorithms, and data transmit to operator. And the seventh task is create only if we needed this functionality. Also, this is autonomous drive algorithm. Our rover was created on Mars condition, and we will to adapting controller to the condition on Mars. We must make some modification of our controller, and this is cover our electronic with insulation and equipped units in heating system, because temperature of on Mars is very low. The second is use radiation resistance processors, and the last we have to make our controller more immune to mechanical damage. And now summary, our controller is a complex system to rover analog steering. We use technology which make us a possible easy device development. We have introduced to our controller many protection algorithms. One of them is real-time operating system, and this system introduces high reliability of our controller, and we hope that this controller is interesting proposal of controller for such robots as Mars rovers. In our presentation, we use materials from Mars Society.org site, FreeEarthos.org, and NASA.gov site. Thank you for your attention.